Decimal representation. So today we are going to talk about number systems, decimal representation. So any rational number or irrational number can be represented as a decimal. So any number can be represented as decimal number, like 4 by 5. How we can represent this as decimal number? So simple mathematics, division in 5's table, it comes at the 8th place. So this will be a 4 by 5 is 0.8. So a rational number 4 by 5 can be represented as 0.8. Similarly 22 by 7, this can be represented as 22 divided by 7, 3 times 21, again 1 time, 4 times 28, 2 times 14, 8 times 56, and so on. Now irrational numbers. So numbers which can't be represented by ratio of two integers, numerator and denominator, are irrational numbers. So root 3, root 3, root 2, root 5. Square root of any prime number is an irrational number. Square root of prime number is an irrational number. So square root of non-perfect squares are irrational number. So root 4 is root 2, but root 4 is a rational number, but root 6 is not a rational number. Root 6 is irrational. So number which are not perfect square are irrational number. If any number is not perfect square, then its square root will be irrational number. 16, 25, 49, 36, 64, these are perfect square. So its square root won't be a rational number. So square root of 16, 4, 25, 5, 49, 7, 36, 6, 64, 8. Hence square root of perfect squares are rational numbers. Square root of perfect squares is a rational number. Square root of non-perfect square. Non-perfect square means 13, 14, 15, 17, not 16. irrational number. Now decimal number. So decimal number can be of many types. One is terminating decimal, like 0.937. So it has terminated after till three places. Now non-terminating. So it is like reoccurring, or if repeating, it means reoccurring, same numbers or similar pattern coming. Non-repeating. So one is repeating, another is non-repeating. First we are seeing the example of repeating 0.111111 till infinity. Infinity times 0.233333 is repeating. 1716. So 1716 repeating every time. Infinity times. Now non-repeating, like non-terminating. It means it won't terminate, but it won't repeat. Like 3, 2, 4, 5, 1, 2, 3, 0, 2, something like going on. Random. So terminating decimal numbers are rational. Non-terminating. So terminating are rational. Whenever you find a terminating decimal number, you should call it a rational number. Like we have seen that. So 5.326 rational, because it's terminating. We can write 5.326 as 5326 divided by 1000. So it's a rational. 5.3 is 53 by 10. It's a rational. So we count the number of places after decimal and put similar number of zeros after 1. So in 5.326, 3 numbers are after decimal, 3 to 6. Hence in denominator it is 3 zeros after 1 everywhere. Now non-terminating repeating. It's non-terminating but repeating. So 3.121212, 6.839839. So non-terminating but repeating. So these are rational. 1 by 3 will be 0.33333. Seven point 6. 7.6 will be obviously it will be a rational number. You can check at your own side what is appearing. Now another example, 8 by 9. 9 times 8, 72. So 0.88. So it will keep on coming. 8 will keep on coming. 8 will keep on coming. Hence 8 by 9 is a rational number. It's non-terminating but repeating. Rational number. Now non-terminating and non-repeating. So it won't terminate, but the repetition is not there. Some random or some different pattern other than repetition. So root 2. You can check at your end what is root 2. I will write up to some decimal places. It is 1.414213562. So there is no repetition. There is no pattern. So it's a non-terminating, non-repeating. Hence it's an irrational number. So by looking at the decimal representation, you can say that whether the number is rational or irrational. So non-terminating, root 2 is non-terminating, non-repeating, hence it's irrational. Now we will move to check whether a given rational number is a terminating or repeating decimal in next video. Thank you.